Hello and welcome to Noel's Retro Lab. Today we're going to take a stock Sinclair QL and look at all sorts of different upgrades to take it to the next level. Here I have a lot of upgrades for the Sinclair QL, so let's take them one at a time, install them in the computer, and let's see how they work. Before we get started with the upgrades, I wanted to say a big thank you to this episode's sponsor, PCBWay. Or is it PCBWay? I don't know anymore. Anyway, PCBWay is my go-to site for creating circuit boards for my projects, and they've always been great. If you're interested, check them out at PCBWay.com. The first upgrade isn't so much of an upgrade as it is a replacement. This is a replacement power supply for the Sinclair QL. And the reason we need something like this is because of two things. The connector for the power supply, it's this really weird 3-pin connector. And the other reason is that the voltages it outputs are kind of weird. So I believe one of them is 9 volts DC, which is totally fine. But then the other one is 16 volts AC, and I guess they have a common ground. So that makes it rather odd. This particular one is made by vRetro, so that's Charlie down in New Zealand. The 3D printed case is awesome. It's designed to be in the same shape as the original QL power supply, just much smaller. I have the original one right here, so it definitely has it's kind of like the baby of the power supply, and also the weight. The original one is really heavy. This one is really light. If anything, it might be too light. The other unusual thing is that this is not exactly a power supply, but a power supply adapter. You don't connect this to mains. Instead, you plug in a 12 volt DC power supply into here, and then this generates the necessary voltages for the Sinclair QL. The button here, I'm not really sure. I guess we'll try it. It's probably some kind of reset, momentary reset, although the QL already has a reset, so I'm not really sure what the point of that is. Let's open it up and see what's inside. Oh, I think it just maybe had a drop of glue somewhere. Right, okay. So very nice and compact. There it says that, the QL PSU 2020 vRetro design by Charlie. I'm not exactly sure what it does. I mean, I can imagine. Obviously, it needs to start oscillating the 12 volt DC into something bigger and then bring it down to 15 volts AC, and then do a conversion of the 12 volt DC into 9 volt DC. So yeah, very neat and compact. Oh, let's see, there's a few more screws. The build quality seems really good. Before we try it on the real computer, let's see the output voltages. I want to see them in the oscilloscope and see what kind of the quality of those. Are they noisy? Are they not? Are they stable? I imagine they are. I'm just curious to try it anyway. So we need to plug in 12 volts in here. And I don't have a good place to hook up the oscilloscope ground, so I'll probably just touch that. And then 15 AC and 9 volts AC are right there. So I'm going to turn it on. And let's see this. This is weird. It's like it's not even connected. So I don't know why I'm not getting any signals in there. Let me just check the ground is connected correct. Oh, wow. So normally on a DC jack, this lead is connected to the outside of the barrel connector, and here it doesn't seem to be connected to that at all. That's super weird, but this is connected to ground. I imagine that's ground, yeah. So that's fine, but that's not. That is weird. I ended up talking to Charlie about his power supply design, and apparently for this kind of power supply, which is a switching power supply, it's not really necessary to hook up the input ground to the ground of the supply itself. So that makes sense. I was just used to the earlier power supplies from the 80s, the analog ones, where it is necessary to hook up the input ground to the ground of the supply itself. I'm just going to measure for now the voltage, and let's make sure that we're getting the 9 volts. And from this to this should be 9 volts. 0.3 volts? It's clearly marked 9, and this is 15 AC. What's going on? And this is... Am I supposed to press this to turn it on? Okay, the light's steady now. I guess I should have read the manual before doing this. There we go, 9 volts. All right. Now let's see if I want to see the 15 volts AC. So I need to hook up the oscilloscope ground somehow. Okay, so it looks like the first cable going to the LED is ground. So I should be able to hook it up right there and connect the oscilloscope probe ground in there. And with this, we can see the 15. So I need to do that. Now I won't forget to push the button. There we go. And yeah, okay, that's looking good already. Interesting how square it is. I'm sure that's fine. And that's clearly an artifact of how that voltage was produced by the circuit. But yeah, that's totally fine for an AC input. It's actually almost closer to 20 volt AC, which I think technically is supposed to be 15.6, but I'm sure it doesn't matter. So, okay. So it looks like it's working. Now let's try it with the computer. Okay, so with everything connected, let's turn on the power supply. And okay, now this blinks. So now that I know that I'm supposed to press the button, and when I do, okay, this seems to light up in here. And we're getting a signal. Awesome. It just booted, no problem at all. Very good. So the verdict for the power supply replacement is that you don't need to get one if you already have a power supply. But if you need to get a power supply, I would say this is a very good solution and I would definitely recommend it. Next, we have the upgrade that I'm possibly most excited about of all of them. The microdrive emulator. This takes an SD card with images of microdrives, and we can plug it into the QL with this cable, like so, and to the QL, and it will act initially, I think, as microdrive 3. Before we do anything with it, as usual, let's see what's inside. Oh, interesting. That looks like, what are those, blue pills? Like 2 of them, too. How do I need 2 of them? Other than that, there's just not much, as usual. Voltage regulator. What are those? Amplifiers? No. I don't know what those are. We'll have to look into it. And, oh, is that already a piezo buzzer? Or is that something else? And then if you want to have more real or emulated vDrives or microdrives, you would plug it in on this side, so they all chain off each other. One important thing about the vDrive that I didn't realize at first is that it's pretty different to some of the disk emulators you might be used to, like a Gotek, for example. What's the biggest difference? The Gotek has some kind of display to tell you which image is selected and some buttons to navigate the different images and select the one you want. The vDrive has nothing like that. No buttons and no display. On top of that, there's another key difference, which is the vDrive is not a single microdrive emulator. It's actually a whole chain of microdrives emulator. So how do we use it then? The vDrive comes with great documentation, explaining very clearly everything from how to connect the drive to the QL to how to create whole chains of virtual microdrives. A vDrive is much more complex than a Gotek, so you should definitely look at the manual carefully. I won't repeat everything here, but we'll go over the basics and we'll run some software from microdrive images. In order to connect it to the QL, we need to remove the lid of the microdrive connector. Then we can plug it into the computer with a special cable. Let's turn the computer on. And yep, it's working. We see the little green light. When you first connect the vDrive, nothing different happens. It's initially mapped to microdrive 3, And if you try to access it without the SD card inside, you see some files. That's what it needs to bootstrap and become usable. For now, let's load it with lrun mdv3 boot. And yeah, that was really quick, and it loaded the toolkit in memory to let us operate with a vDrive. When you type help, it shows you all the commands. 2 screenfuls. I told you this was not trivial. You better read the manual. Let's start by preparing the SD card. We run sd init, and it formats it correctly and writes a configuration file. Then we can start making new images with the command make image. And running li list images shows us all the images we have in the current directory in the card. An image can then be loaded with the command ld and the microdrive we want to add it to. In this case, I'm adding the Noel 1 image to microdrive 3. And with the lv list vDrives command, I can see the current ones. But wait, we're not there yet. Before we can even use that drive, we need to format it, just like a real cartridge. And if I try to load another image, I can't, because the vDrive is only emulating one microdrive at the moment. If I want to add another one, I need to tell it to create a new drive. And now I can load it and format it. Phew! But wait, there is more. As if this level of configuration wasn't enough, we can create banks. A bank is a particular configuration of images and vDrives. So I could set up one bank for working with the word processor, another for development, etc. You can really customize how you want to work with a vDrive. So at first it seems a bit intimidating, but once you get started using it, it's really good. You're not limited to using image files you create yourself. You can download MDV files from the intranet for different programs, copy them to the SD card, and use them in your QL. In this case, I got a few freeware games, so let's check them out. I tried a couple of them, but they refused to work. I don't know whether the image was corrupt, or they didn't like something about my QL, like the Minerva ROM, or they simply didn't like running from MDV3. But I did find one that worked, Pac-Man, or at least that's what it's called. The game itself is pretty abysmal and nothing like the original Pac-Man, but I'm just happy to be able to run a game at all. I hear there's some good games for the QL, really, especially text-adventure ones, so I'll have to cover those in a future episode. For now, let's try running one of the flagship programs for the QL, QL, the word processor by Scion Software. I tried running it from cartridge before, but I wasn't able to run it properly. And oh, bummer, same thing. These programs don't like running from microdrive 3. I need to fix that. I wish we could set the vDrive as microdrive 1. So in order to change which microdrive the vDrive is, we can use a vMap, also conveniently sold by vRetro. So it almost looks like it's just a cable and some pin headers, but actually there's a tiny microcontroller right there. So each microdrive has 2 ribbon cables going into the main board, and these are usually horrible connectors, but I believe these have been upgraded, so this should be easier to disconnect than the stock ones. So the inner one needs to go on this set of pin headers and back on the board. Yeah, that was really easy. And then the vMap connects in there, but we might as well do that one first. And now the other ribbon cable goes on the vMap, and then the vMap goes on that connector. So the one with the actual microcontroller is supposed to be in drive A. Okay, that was very easy. And now we just need to put this back in place. There we go. So this just this cable connecting the two. Just move that out of the way and put the heatsink back for the moment. The vMap, again, has really good documentation. In this case, it's pretty straightforward, and it mostly comes down to the vMap command, which chooses a configuration from this table. The default 1 has the 2 internal drives mapped as 1 and 2, and the vDrive starting at 3. You can see that by typing vinfo, and there you go. In the last line, it says vMap 1. That means we're in that configuration. But if we change it to vMap 3, now we have the first 2 drives mapped to the vDrive, and the internal ones as drives 3 and 4. So let's check out drive 1. Yeah, there's the image of Quill. Let's try launching it again. Now that this is MDV1, it will hopefully work. And yes, it worked. This is the first time I've managed to load this program on the QL for one reason or another. So the vDrive and the vMap are an amazing combination for the QL. There's only one thing that I wish for, and that's I wish it made some noise while it was accessing the files on the drive. And for that, there's already a solution. Next, let's connect the Whirr emulator, or whatever they call it, the thing that makes noise on the vDrive as you activate it and use it, trying to emulate the sound of a real microdrive. First, let's solder the cables, and then we'll figure out where to put it inside of the drive. The instructions that come with it tell us where to solder each of the cables, so that's pretty straightforward. Okay, time to test it. Oh, that doesn't sound very good. I know it's trying to emulate a little bit the original sound of the microdrive, but it doesn't even sound like it very much. Let's try it with a real microdrive and compare the two. Yeah, I mean, this is not exactly a pleasant noise either, but it's much better than the electronic high-pitch noise of the Whirr emulator. Let's compare the two again. I have to admit, I don't like that sound at all. Now, I didn't grow up with the QL and loading things from microdrives, so even the original microdrive loading sound doesn't have any particular appeal to me. So instead of trying to replicate that, what I'm going to do is try to add some audio feedback while the microdrive is active. This is particularly important on a Sinclair QL because unlike other computers of the time, it actually multitasked a fair amount. So it may be doing things on the screen while it's still loading from the microdrive. And that feedback is pretty important to the user. So to see if we can improve the noise that this makes, let's have a look at the signal exactly where we hooked up the Whirr unit, which is right before this resistor. Okay, so that looks like variation, but only between 5 and 3 volts. So there's like a 2-volt offset. So I think the easiest way to try the piezo buzzer is going to be to get a couple of wires to ground in the signal we want, send them to the breadboard, and then we can connect the piezo buzzer with these connectors, like that. And now we need to solder some wires here. These wires are obviously just temporary for now. If we like it how it sounds, we can come up with a more permanent solution. Okay, and with everything plugged in, let's turn on the Sinclair QL. Okay, so we're not getting anything. We're getting a red light, so we should be hearing something already. So maybe the problem is that the oscillation isn't right for the piezo buzzer. Maybe it needs to go all the way down to 0 in order to trigger it. So I'm just going to measure the same thing that we're measuring before, that lead in the resistor. Just going through the breadboard is more comfortable right now. There we go. And, oh. So now we're getting a steady, completely steady 5 volts. The only thing I can think of is that this particular unit was bringing down that voltage. And then the whole point of this microcontroller really was to generate a some kind of oscillation, given this signal is steady, which makes sense. If you're sending that to an LED, you probably want to send, and it looks steady. Okay, so as an experiment, I've set up a very, very simple circuit with a 555 timer. So all this does is generates a square wave on the output. I wasn't too picky on exactly the duty cycle or the exact frequency. I just wanted something relatively low frequency so we can easily hear it and it wouldn't be an annoying whining. So I picked, I think it was like 1K resistor, 2K, and 10 microfarads. And the output is in pin 3. So when I turn this on, so this is not hooked up to the QL at all. I have this hooked up to my power supply. So this is 5 volts that we're feeding into it. And just for testing, we're going to see the output wave. There you go. That looks totally fine. What's the exact frequency? Let's see, is it going to tell us? It's about 30 hertz. That's great. Okay, so let's actually listen to it and see if that's what we want. So I'm going to connect the piezo buzzer, and one of them, the one lead, will go to ground and the other one to the output of the timer, which is exactly where we were looking with the oscilloscope. And I power this. So that's great. That's a lot less annoying than what we had before. Okay, but right now this is only powered by 5 volts. Let's remove the 5 volt connection and instead connect it to the signal that turns on the red LED on the vDrive. So let's turn on the QL. Honestly, that's better than it was before. One interesting thing about setting up the buzzer this way is that we can change the frequency of the sounds pretty easily just by changing the capacitor. So I think I had selected, this was what, 10 microfarads? Yeah, this is 10 microfarads. So let me grab something like 100 microfarads. This should make it much slower, maybe even a tenth. So if the other thing was 30 hertz, maybe that might be 3 hertz. So this might be like, you may hear more discrete tick, 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 which it's fine. We're just looking for an audio feedback. So let's give this a try right now. There you go. That's pretty nice. That just tells you, hey, I'm on. I like it. So just for fun, let's try a different one. I've turned this off. Let's try 47 microfarads. And that should be something in between the two. Let's see. Yeah. Yeah, I don't know which one I like better, actually. This definitely has more energy to it. Like, it makes you think like, yeah, the microdrive is definitely doing stuff. I might go with this one. I had some of this prototype board and I didn't have a neat saw, so I just snapped half of the board. So I did this arrangement thinking about how the resistors need to be and where things are connected. The output would be right there. And then I'll hook up ground there and 5 volt, well, not 5 volts, but the activation signal there to F. Okay, so there's the final result. I had to add this little cable to connect reset to VCC. Let's actually test this. I've already soldered the wires in place. Now let's hook up the piezo buzzer. There we go. That's perfect. The last step now is to hold this in place. So what I'm going to do is I'm just going to put a bunch of hot glue there and then put it on top. The hot glue is not conductive and neither is this, so it should be perfectly fine. Just need to hold it in place for just a little bit. And there you go. As for the piezo buzzer, it really doesn't matter. It's not really conductive. It can be loose in there. I thought about maybe putting it under the board. Maybe that would work. So we could leave it loose like that. Or, let's see. That would hold it more in place. Yeah, I like that. Okay, time to do the final test. Yeah, much better than before. I like it. And so these upgrades, the vDrive by itself is pretty good, but once you combine it with the vMap, it's simply a must-have upgrade for the Sinclair QL. The Whirr unit, skip it completely. You can either make your own like I did here or look for alternatives, but that one is definitely not worth it. Mike over at 8-Bit Retro Journal is quite the Sinclair QL enthusiast, and he's going to be publishing a series of videos about adding sounds to the vDrive. So definitely check out his channel. I put a link down in the description. Well, that took a lot longer than I expected, and we ran out of time, so we're going to have to save the rest of the upgrades for another episode. It's actually all the upgrades that go inside of the computer, so that should make a nice theme for it. Anyway, I hope you enjoyed this video. If so, please give it a thumbs up as usual and subscribe to the channel. Until next video, see you then. If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.